We're live. Hello, everybody. We're live in another video. Um, you might notice that we don't have our camera, and that's because uh, I think I took it out of the room. But it's okay. I mean, I'm just using this one, so it's all good. It's all good. In today's video, we're going to be reading some programming assignments. We already completed all of our actual coding projects that we had to do. So all we got to do is simply finish some reading assignments and do like a couple of quizzes. That the easiest part. It's not going to be critical thinking. Here is just going to be reading. So it's fun to do that. Regarding calculus, which we have not done a stream in a while, I believe it's been almost a week or something. Regarding that class, we're actually doing pretty good. I was considering dropping out after I took the test, my first test, and I think I got a 75%. Not the best, but not the worst. I found out that the average of the tests of the class was like 64%. I mean, yeah, this is a 6-week accelerated calculus weed out course, so it's difficult. We're almost done with module 2 for calculus. All we need to do is simply review for a test that's due this Monday. But today we're not going to do calculus. We will be doing our programming class, object-oriented programming, and we're in module 3. We're doing object-oriented programming with inheritance. So that's going to be very fun, and I believe I will. Oh, I don't think I can share my screen. Can I share? I don't think I can share my screen, so I think you'll will just watch me. Watch me read. Yeah, there's not much to talk about. We have a bunch of reading to do actually, but it's like not a lot of brain power. So I hope that this goes by quickly. Well, let's do this. No reason to not begin now. 14.3, specifying the public inheritance of a class. Gotcha. When designing a class, you start by specifying its public inheritance. Oh, sorry, interface. Public interface, not inheritance. The public interface of a class consists of all methods that a user of the class may want to apply to its objects. And the definition of public inheritance is the features of a class that are accessible to all clients. I understand. So, like the methods and the variables that are public, I think that's what I understand. I don't think private features are accessible outside a class. Hold on. What did we see last chapter? Oh yeah, implementing a simple class. I think we understood everything here, right? Yeah, very good. And what was number 1? Oh yeah, just talking about object-oriented programming. Very good. All right, here we go. Let's consider a simple example. We want to use objects that simulate cash registers. Cashier who rings up a sale presses a key to start the sale, then rings up each item. A display shows the amount owed as well as the total number of items purchased. In our simulation, we want to call the following methods on a cash register object. So a method for add the price of an item, a method for get the total amount owed and the count of items purchased, and then a method to clear the cash register to start a new sale. And yeah, here's a little outline. We have our class cash register. We have our private data C section. Oh, let's give a link. All right, we have our, oh, okay, so they tell me the implementation in different parts of the reading. It's okay. Yeah, so we have our class, a method public void add item, and we're going to receive a price. Another method get total, another method get count, and then another method void clear. And all of these, they are all public, and I'm guessing they're public, so outside classes can access these methods. I understand. The method declarations and comments make up the public interface of a class. Hold on, let's go back. So let's think. Gotcha. The method declarations and comments make up the public interface of a class. The method declarations and comments. The public interface of a class. Okay. The data and the methods and the method bodies make up the private implementation. Oh, I understand. So the public interface is basically what the user can see or what they need to know, and private implementation like of the methods, they don't have to know it. Gosh, that was a horrible explanation. Hold on. What is a public? Yo, stop. Public interface in Java. I understand. I get it. I get it. Okay. Note that the methods of a cache register class are instance methods. Excuse me. Note that the methods of the cache register class are instance methods. Right. They are not declared as static. You invoke them on objects or instances of a cache register. I understand. To see an instance method in action, we first need to construct an object. So here we construct our object, cache register. Register 1 equals new cache register. This statement initializes the register 1 variable with a reference to a new cache register object. Oh, very cool. So this keyword register 1 is a variable and it references a new cache register object. That makes sense, right? This is a good diagram. We have a register 1 variable and that stores a reference, and that reference points to the actual cache register object. Once the object has been constructed, we are ready to invoke a method like dot add item 1.95. When you look at the public interface of a class, it is useful to classify its methods as mutators and accessors. A mutator method modifies the object on which it operates. A mutator method modifies the object on which it operates. I understand. The cache register class has two mutators, add item and clear. And I guess by definition, that modifies the object in which it operates. Cache register. After you call either of these methods, the object has changed. You can observe that change by calling the get total or get count method. So the definition of a mutator method, a method that changes the state of an object. An accessor method queries the object for some information without changing it. Like a get total, I think. I think that's an accessor. Whoops. The cache register class has two accessors. Get total and get count. I understand. Okay. Okay, this makes sense. Returns a value, does not modify. The definition of an accessor method, a method that accesses an object but does not change it. So yeah, register dot get total, that is an accessor, and dot get count is also an accessor. Do we need now we know what a cache register object can do. Now we know what a cache register object can do, but not how it does it. Right. Of course, to use cache register objects in our programs, we don't need to know. In the next sections, you will see how the cache register class is implemented. Here's a documentation for the public interface of the cache register class. Okay, very cool. Suppose we want to design a class day for working with calendar days, such as January 1, 2016. Specify methods for the following operations. What is going on? Sorry. A get month method. A get month method. I understand. It gets the month as an integer between 1 and 12. Oh, okay. Like either as mutator or accessor. I think that's what they want us to do. Well, yeah, this is an accessor. How do you spell accessor? Accessor. Yeah, accessor. Oh, do you want me to write accessor method? What is it? Oh, you want me to write the like the actual syntax? Oh, specify methods. Okay, that's what you meant. Yeah, so public returns an int, get month. We are not passed anything. Oops, no semicolon apparently. Get month name. They get the month as a string, such as May. Um, public int. Whoops, public string. Get month name. Okay, good. Add days. Now this is a mutator that returns the calendar day that is n days from 1. Oh, add days simply returns the calendar day. Public int add days that returns the calendar day that is n days from 1. Um returns the calendar day. Let's see. Calendar day, calendar day. The added days method that returns the calendar day that is n days from this one. Okay, let's see. Oh, okay. So you got to pass into n. I mean, we're close. A move by days method that moves this calendar day object by n days. I'm guessing public. Let's see. Void. I don't think we need to return anything. Move by days. And we will return 1. Let's see. Let's see. Let's see. I believe that's good. By n days, so I also need int n. Good. A constructor that constructs a day with year y. With year y. So I believe I'll have day with year y. day, how do you, oh, so I believe what I've, oh, day as an integer between 1 and 12. Oh, I understand. So I think I want to do, yes, so public day. Right, of course you got to put the public constructor. With year y and month m. So I want int m, int y. Oh, whoops. Int d. How about that? Oh, good. Cool. The following walkthrough code uses two cache registers. Uses two cache registers. I understand. The following walkthrough code uses two cache registers. I understand. Track variables in a trace table on a sheet of paper. On a sheet of paper, make the table below. Okay. Lines 1 through 5 execute. What is the value of counts? So register 1 dot add item 5 2. Hold on, by the way, what does the get count do? Gets the number of items in the current sale. Oh, okay. 1, 2. There you go. 6 and 7 execute. What is the value of total? An item of total. Well, that's also 2. Oh, it's not. So we add reg2 dot add item 20. And we had, oh, my bad. We never added something there. So it's just 1. Not. What is get total? Now is get total money? The price of all items, bro. So that would be 20. Line 8. What is the value of count? Count plus reg2 dot get count. So that's 1. 1. Count equals count plus reg2 dot get count. What is count? Oh, reg1. So what is it? 21. So what was reg1 dot get count? It was 20. Now count equals count plus reg2 dot get count. So 20 plus 1. So 21. Well, why is that wrong? Oh, because we had 2. 2 plus 1 is 3. My bad. 3. 9 and 10. What's the value of total? So clear. Well, 0. Rearrange the following lines of code to construct a cash register. Process a sale of 3 items under $10. Print the count and then the total. So we need to construct a cash register. I understand. Process a sale of 3 items. Oh, under $10. Print the count. Print the count. Okay. Clear. Process another sale of 2 items. Over $10. Okay, that looks good. Okay. Let's see what's going on. What's going wrong here? Uh, system that on the okay. Okay, sorry. So clear the register and process another sale of 2 items. Of 2 items, bro. In the same way. So under 10, print the count and then the total. Oh, whoops. I get it. I think I forgot to get the total here. There you go. That looks good. Hold on. Let's see if it worked. Very good. Okay. Classify the given methods as accessors or mutators. Add item. Let's see. What is that going to be? Is that an accessor or a mutator? An add item. Well, we're adding. I think that's a mutator, and we're right. Adding an item to a cache register updates the count and the total. Right, we're updating something. We're updating a feature of the class. The get total method of the cache register class. Well, that's obviously an accessor. Clear mutator, I believe. Get value accessor length. What is length going to be? Oh, the length method of the string class. I think that's an accessor. Yep. To uppercase. That's a mutator. That's not a mutator. The string is not changed. Interesting. So it's just an accessor. The next int method of the scanner class. I think that's an accessor. It's not an accessor. You don't know what goes on inside of the scanner class, but you can tell that the call next int must mutate something because each call can return a different value. What's up, Bear? Okay, I understand. Okay. Consider the following code snippet. Day, then we have 3 private variables, day of month, and then year. And then we have our constructor get month that we don't know the implementation of. Assume that object birthday is an instance of the day class. Which of the following statements is a correct way to call the get month method? So we have birthday.getMonth. No. Day.getMonth. I think that's the way to do it. And yeah, our constructor does not have anything inside, so I believe this is get month. Oh, sorry, the get month is a constructor, so we just gotta call. You just gotta. I mean, well, if you call day, that's like the automatic constructor. So to call the get month method, let's see. Oh, birthday dot get month, right? Because birthday is an object. I forgot. All right, well, that's the entire chapter. Let's continue. Now, what's going on here? Greetings, mortal. Mortal greetings. What's up, guys? Welcome. Next stream, you should share your screen so we know you're not cheating and see the cool coding colors. Love from KT and Tony. Oh, what's up? Hey, guys. It's good to see you. Yeah, I don't think I can share my screen because then I might get like a copyright warning or something. So that wouldn't work. What we can do, let's see. If I share, what should I share? Because I can't do the books because I might get like a copyright warning. But I guess I could try to share something else. Yeah. Okay. 14.4. I think I'll try to be a little more quiet now. Here, I'm just going to close the door. Hold on. Okay. Okay. Stores prices. If the cash register stores. Right. Here's well. Okay. Okay. All items. Add item. 17. 19. What is the value of prices? Line 19 executes. What is the value of prices? Let's see. So we added 5. prices sub 5. All right, we're allocating 5 to the variable, the double variable price. And then we have our array. Is that an array list? Array list, I believe. So now, or array? Okay, now I don't know. I can't tell. So array sub count. Where's count? So I think count is 0, right? Yeah, equals price. 5. Line 20, what is the value of count? 1. Okay. The next line execute after line 20 is going to be, now I believe we go back to the main, so 7. 17 and 19. Chill, what's going on there? What is the value of prices sub count? Let's see. We added an item. I think it resets. So 7, 1. Oh, it's not 1. 0. Is it 2? Why is it 2? Like, does everything save after? Interesting, bro. Okay. The next line. Okay, no. This is important. It's important to understand. Line 20. What is the value of count? So new 7. Then we go to 17. Prices. Sub count. I mean, this is a private int, so I could expect that everything here. What's up, buddy? My dog is just looking out the window. What's up, Bear? What's up, bro? How are you, Bear? See, so okay, count equals 2. Next line after line 20 is going to be 8, I believe. Next line's 28 and through 33 execute, completing the first iteration of the for loop. What is the value of total? 28 to 33. What is the first value of total? What is the value of total? My bad. Yes, if total is 0. I less than count. We set at the count. Well, that's going to be 2. So total equals total plus prices sub 1. Sub 0. And then that's going to be 5 and then 7. So total equals 0 plus 5. So now total equals 5 plus 7, 12. Yo, what? All right, I equals 1. Now total equals 5 plus 7. That's 12, right? Oh, first iteration, 5. Then 7. 12. Next, the for loop completes in line 35 executes. The next line executed is line where do we go back? Well, that's it, right? 9. And line 35 executes. So after the return, 8. What is the value of amount due? Well, 12. Whoops. In the preceding walkthrough, you observed a cash register implementation that chose to store the prices of purchased items in an array. Suppose an array list is used instead. Rearrange the following code to implement the add item and get count methods. Right. Um, okay. Very good. First try. How many? All right, we have one challenge. Oh, cool. Okay. We're almost done with this chapter, and this is 14.4. We should. We should play Minecraft. Yeah, that's a good idea. Okay. So what do I have to do? Let's see. Let's see what I should do. Suppose we needed to add a support to the cash register class from the preceding problem to enable the cashier to quickly undo the preceding purchase that may have been entered incorrectly. This will require the use of a third instance variable to keep track of the previous purchase. Right. Complete the following class definition to implement this new feature. The undo operation only undoes one purchase. It will have no effect after calling undo, give change, or clear. So where do we add? Oh, right here. We add it right here. So private. Um. Oh, to keep track of the previous purchase. And a purchase is price, and a price is double. So private double previous purchase. Purchase. There you go. So item count plus plus total price equals total price plus price. Right. Uh-huh. And previous equals price. Undo the last entry. So do we add like a new method? Public void undo double price. So total price minus equals price. I think that should be good. Oh, do you want me to do it? Hold on. Okay. Okay. I think I did it well, but there we go. Total price equals total price minus previous. Minus previous. Oh, so I got to receive previous in here. Item count minus minus. And what else do we do? What else do I do? Let's see. Yeah, so items count. But your code, okay, hold on. Previous. But your code goes here. But like, what code? What do we need to do now? Oh, this will require the use of a third instance variable. Keep track of the previous purchase. I mean, that looks good. And then previous equals 0. Whoops. Let's see. So the undo operation only undoes one purchase. It would have no effect after calling undo, give, change, or clear. So what does give change do? Oh, change equals negative total price. Change equals previous, I believe. Oh, wow, dude. So undo, oh, and add item. Hold on, add item. All right, we added it. Cool. So undo. So item count minus minus, and then we have total price. Total price equals total price minus previous. Previous now equals 0. Let's see.
What's up, Bear? What's up, buddy?
Dude, I'm confused. What do I do here? The way they explain this thing is very incomplete. Mm-hmm. Oh, whoops! I did put it capital. Oh, so I think I gotta take that off then. Let's see if that works. Okay, we were close. Oh wait, I think I know what I did wrong. Maybe that should work. Okay, so that does not work. And if how about that? Does that work? No, so I was good before. So now the thing wrong is the change. Keep the change. All right. So what happens if I do that? I think I'll get one thing wrong, but I gotta fix that. So 16.72 and then negative 0.00. Hmm. Actually should be greater than 0. There you go. I think that should work. Bro, why is what's going on? Change 2. Hold on. So give change. This is working give change. Let's see. Yo, okay. Oh, so it looks like I need to reset something. Let's see. Results on change 2. Let's see. So what should I do there? Should I do change equals 0? Dude, oh my gosh. Oh, I gotta do previous. That's probably it. Oh, yeah. Oh, that should work then. There we go. That's better. Instance variables. Well, that's going to be 3. Correct. Okay. So 30 and 31. Okay. Value of purchase in reg 1. Core to purchase, where is that? So amount. So 15. 15 equals 15, so I think that'll be 15. 32. What is the value of payments? Oh, receive payment, 20. Well, 20, right? Line 33. Reg 1 dot give change to customer. What is the value of change? Okay. So payment. So what was the payment? Payment was 20. 20 minus 15. Purchases here. 5. Value of purchase in reg 1. 0. Payment is 0 as well. Value of purchase in reg 1. Well, it'll be 2. 35, the payment would be 10. And 36, the change would be 8. Very good. And that's another chapter completed. Let's go. Well, I'm going to go quickly to the bathroom. Okay, we have the 14.5. Let me see how long these other chapters are. It's loading. All right, this also looks pretty long. Then we have this. All right, it looks short. Doesn't look too long. To class. Not bad. Not bad. All right, looks a little long. Pretty easy. A little long. Not bad. Not too long. It's okay. This one looks very long. Not too bad. No, very easy actually. Very short. Well, okay. How many is there to read? Yo. Okay, hold on. So let me just see at everything I have to read so far. where are we? So this is objects and classes. Yes, we've been told 4.18. Okay. Then interfaces and inheritance and interfaces also looks very long. And object-oriented design. Cool. Well, that's all fun. Let's play a single game of Gold Pario, and then we'll be back to reading. What? All right, let's get back to it. So 5 and 6. X, hold on. And what did he learn? A method other than the object. A parameter of a method other than the object. Okay. Implicit parameter. I understand. Okay. Double result equals cube volume. Static methods. Uh-huh. Register 1 to add item. Mm-hmm. Such as item. In the method. The notes. Item count of the register 1 object. Mm-hmm. Before the method. Parameter. Yeah. I understand. Okay. Item is added. When an item is added, it affects the instance variables of the cash register object. Wait, when an item is added, affects. Parameter. Every instance method has exactly one implicit parameter and 0 more. Let's see. Oh, gotcha. Remember, if is past explicitly. So static methods do not have an implicit parameter. I understand. Right. It makes sense. If you have a method of the class, you don't have to pass the object of the class. However, if you're outside of the makes sense, yeah. Right. Precisely. Explicit. So we have price and then we have nothing there. Five. $28 and $30 get total. Very good. All of them correct. First try. You'll have to provide 2 additional cash register methods. Change. Change total price. I think that should be good. Let's see which one. So we have a 3 and 0. Oh, the only thing is a negative. Well, I should have gotten a 0 here, but we got a 3. I should have gotten a negative. Let's see what happened here. Give change. What's the difference between this? Oh, it's just the negative sign. Let's see. Oh, whoops. Yeah, here the remaining items in the cart should be 0. Why is mine 3? Oh, of course, I gotta make these all to 0. There we go. Oh, whoops. No. Hold on. Amount. There we go. We put that one before. Amount equals amount minus total price. Total price equals total price minus amount. Wait, hold on. What? Enter payment. Reduces the total amount by the given payment. Let's see. Think. Oh, and resets everything. There you go. Perfect. All tests passed. All tests passed. Gotcha.
What's up, buddy? What's up, Bear?
20. 20, 27. Oh no, hold on. Yeah, 27. 40, 51, 52. Oh no, sorry, 30, 31, 42, 42, 29, 69. Oh, little. Okay. Oh yes, I I can see your name. What's up? What's up, guys? All right, let's finish this. So we have lines 5, 6, and 18. 15. Purchase. Oops. The parameter variable of record purchase is created. Parameter variable. Initialize the parameter variable. Oh, so amount equals 15. Purchase equals 20. Whoops. 15 as well. When the record purchase method ends, which variables are removed from memory? Good question. Amount. Bro. There you go. Lines 7 and 23 execute the parameter variable of the receipt payment method is initialized. Well, amount 2, that's going to be, what was it? 20. Payment is 20. Amount 2, so B. Lines 8, 28, and 30 execute. Lines 8, gift change, and 30. Payment minus purchase, that's going to be 5. Whoops. Update the purchase instance variable. What is it? Oh, 0, right? Yeah. When the gift change method ends, which variables are removed from memory? Payment, payment and purchase. Purchase. Oh, well, D, right? Both B and C. Why is that incorrect? Is change also? Oh, because it's in an entire class. So yeah, all of the above. Is it only change? Oh, I understand. Okay. Hold on. So that's 1, 2, 3, 4. This is variable purchase. Purchase. Oh, well, 0 then. All right, good. Hmm. What?
Last year?
Well, yeah. Wait, look, look.
Yeah.
Yeah. Oh. Chucky. Oh, cool. Okay. It's awesome, man. Well, everyone, I think I'm just gonna end the live stream right now.